In this episode, our experts break down the difference between public and private AI and uncover the pitfalls and challenges of each process. From huge hardware and energy costs for training your own data to challenges when placing your business data outside of your network. What's the best way to accelerate your AI journey? And do you even have enough business data to train an AI? It's a strange new world. In this episode, we're delving into the realm of AI. But we thought we'd look at something specific. Public AI versus private AI. Christian Moen is our resident expert on the subject. So over to you, Christian. What the hell is the difference between a public and a private AI?
Well, it's the same with everything else. I mean, it's private data center, so a public data center, right? So it's kind of the same differentiation between them. You got the public AIs like ChatGPT or Copilot by Microsoft and the others, where you give your kind of data or questions and queries to a publicly available AI engine of some sorts, for the most part, based on a large language model or something like that. And the private part of it is interesting because there might be data you don't want to feed into a public AI. You don't want it to be able to, someone else to get access to it, or you don't want someone else to be able to view your queries or look at your data that you're modeling on. And that's where the private AI comes into play. It's basically AI in your own data center.
And this is maybe something that people don't really understand. So if you want to use a public AI, you are feeding that public AI your own personal data, and there's a format for doing that. Do you pay for a big chunk of storage on the AI provider's website and send it data, or is it something you can just do within your business?
It's both, really. I mean, ChatGPT, you can just feed it a document and tell it to summarize it or do something with it. When you look at Copilot from Microsoft, for instance, it's an add-on that it is available in Word and Excel and Teams and whatever, where it can actually look at whatever you're putting into it and then provide something of, hopefully, some value back based on that. But when you do that with Copilot or the public ones, you don't really have any control of where your data is. You don't have any control of where you want to. I mean, there was a story a while ago where Samsung engineers put their source code into ChatGPT. And that's proprietary information, IP from their company, and they're feeding it into a public.
That doesn't sound like a good idea.
Who knows what happens with it? Exactly. So, and that's where the private AI part of it comes in, right? So if you want to design a private AI now, what you probably should do is treat it as any other data center centric service that you have. So you put it into your own data center on your own hardware, and you feed it with your proprietary internal information and get value based on that. The problem with that is building a big AI rig locally. It's kind of expensive.
I can imagine it is.
It's also really, really hard to do because, well, there's a reason why NVIDIA is such a highly valued company on the stock market right now, right? Because there's a shortage in GPUs. So the way you would do that is basically there is a lot of available large language models out there. Meta has one, Llama 2, Llama 3 is a newest version of it, where you can actually go and download that large language model from a website called Hugging Face, which is a public repository of large language models that you can use. You download that into your own data center. It's just a file, albeit perhaps a big file, but it's a file. It's nothing else. It's not software in that sense. You don't run it as a software package. It's just a file that you use in your own models. And then you augment that large language model that Facebook or Google or wherever has trained on large data sets with your own data. So you put your own local proprietary data into a vector database besides the large language model that's been trained on public data. And then you kind of tweak or retrain the large language model with your specific data. And nothing ever leaves your own data center. And you can do that on a smaller footprint AI installation in your own data center instead of having hundreds and hundreds of servers.
This is the thing. So the assumption is really that you think of these large language models as containing all the data that they contain, but they, i.e., all of that knowledge. But that knowledge is actually learned by. So the large language model is like a neural network, isn't it? So essentially, it's a neural net to think about how these things work. It's not actually the quantity of data. So sitting behind ChatGPT is not 80% of the internet all separately held in ChatGPT. There is an engine that is the large language model, and then the data is elsewhere. So you could just download the brain, essentially, which is the large language model, to your own systems, and then add in, I don't know, a sub-brain that is related to your data only. Is that how it works?
I would just jump in a little bit. Christian, you said with Copilot, that's just public AI. I would jump in there because there is a very, very hard differentiation, I think, between the Bing Chat Copilot thing that is available for everyone, which is the same model as ChatGPT. You can upload things. It will be used for everyone to be trained on. And then there's this company Copilot added edition for, let's say, Microsoft 365, where the public model itself, the large language model itself, is used on your data, but your data is not being fed into the language model and the learning system. So the data that you query is staying in your tenant. I think that's very, very important. And I think that will be the same for the other large language models providers like, I don't know, Google.
Cuckoo, what is raining today?
Whatever the name of their AI is at the moment, when you use them in the workspace context of their environment, the data will stay in that realm also. So all your access policies apply, all your permissions apply. So it's not that when you put something up there in the business context with you pay money for that option, then this will stay private as it stays in your whole Azure tenant or Google Workspace tenant or whatever.
Yeah, that's the kind of restrictions that Microsoft has put on that, right? So your company Copilot is restricted to your tenant in Azure. But at the same time, there's a lot of local data that customers don't want to put into Azure because they don't know what might happen with it, where it's stored. There are a lot of regulations and personal information, GDPR things to consider and stuff like that. So if you look at health records or things like that, you have to kind of anonymize that data before you give it to some sort of private/public AI inside of a tenant, right? So if you want to do that on local data, you can still do that without the data ever leaving your data center at all. And that's the main differentiating thing here, right? So using Copilot inside your Azure tenant, if that's fine with the data set you're providing it with, there's no problem with that. But there might be sensitive data that you don't want to have leave your data center at all. I have one example that I know of is that VMware internally they created they used one of the models from, I don't know which one of the models from Hugging Face, and used it in their own data center and trained that large language model on their top 10 coders internally on their code, basically, to figure out how to best develop VMware's own source code internally. And of course, unlike Samsung in that example, VMware doesn't want to give that away to somewhere else where it might potentially leak or they don't know where it is. So they use this locally. I think their example was that they had about 35 megabytes or something like that of actual code.
Which doesn't sound like much, does it? That doesn't sound... In reality, I suppose the way the text works, actually, that's quite a lot of characters, but it doesn't sound like much data from an AI perspective.
It's not much data, right? So, but being able to create that initial large language model would mean that VMware or someone else would have to have hundreds and hundreds and hundreds of GPUs to create that large language model. In this case, someone else did that. I mean, right now, I think Meta or Facebook owns about 1 in 6 NVIDIA GPUs, H100 GPUs available in the world. They have that in their data centers, so it's no wonder it's hard for someone like us to get one.
So can I rent my home computer with my graphics card to Facebook? Do you think is that going to work? Maybe.
Yeah, you're back to Bitcoin mining then. But yeah, it's the same thing. But getting to the point of my example was that they could use someone else's large language model that had done all the really, really hard GPU work on, and use that model and augment it with their own data and provide an internal service where they have call it their internal co-pilot within their developers' IDEs, where it actually suggests that if someone writes some code and it's not adhering to the code standards, it would pop up and say, well, this is how we would do it internally in VMware. This is how it should be documented. This is how it should look like. And you can do that with a much, much smaller footprint now, if you do it with a publicly available model and augment it with your own data. And that's where the value comes from. And it also makes it a quicker way to market for doing local things, because you don't need to buy all of this hardware to be able to do it.
You don't need the massive quantity of data to train it. I think that the thing that we're not really getting from this is large language models are called large for one reason and one reason only, and that's because the amount of data they threw at them to make them work is enormous. And I think I'm not sure that most businesses generate enough data to be able to do that sort of training. It's just not there. And like you say, 35 megs worth of code for VMware. You would expect VMware to be a code-based business. You'd expect them to have terabytes and terabytes and terabytes worth of code, but they fed a very small amount of that code in to be able to train it. So, that's a big difference.
And I think they decided to create an expert system and not some kind of general answering machine. I think that is really, really also helping to keep it low and to help with the accuracy of answers, because the more data you try to use and commingle there, the greater the chance of so-called hallucinations are, I think, where the system just makes up things. And when you strip it down and you really have this based on facts data set, and you tell the model you don't just think about something, just use this as a fact, then you can rely way more on the results than just having ChatGPT throwing in anything. Because
imagine using the entire GitHub, all GitHub public repositories as your source of truth for how you should code things.
Wow.
If you do that, the chances are that the code you're going to get back from that large language model or that private AI or whatever you want to call it is likely not to be great, right? Because there's a lot of stuff there. Yes. And I'm big on, we've talked about this offline, but I'm big on doing home automation stuff, right? With Home Assistant and stuff like that. So a while back, the Home Assistant support forums online banned the use of ChatGPT as a way to answer other people, right? Because what happened was that someone asked a question, how do I code this? How do I do this automation or whatever? And people would jump in and they would just ask ChatGPT. It would provide some code. They would paste it back in the forum as, this is how you do it. That code might not work, right? No one verified it. ChatGPT at that point was based on data that was a couple of years old. And if it's on the official forums, people might actually start taking it as official documentation of how it should work. And it didn't, right? So they had to kind of ban the usage of ChatGPT as a way of answering it, because the code it produced didn't necessarily work. And that's the same problem. It's based on publicly available stuff. If I put a bunch of wrong code out there for Home Assistant, ChatGPT might pick it up and just tell it to someone else. So this is the truth. This is how you do it, and might not work at all.
Yeah,
code might be crap.
It's a way to read a lot of blog posts done by people.
Yeah,
very, very fast.
Yeah, no, I've got to say, and I use it for just that. At the end of the day, I occasionally, it's faster sometimes to sort of go to a Copilot or ChatGPT and say, right, I want to write a function to do this. It's got to take this input. It's got to do this to the data. It's got to provide this output. Go ahead and do it, please. And it will provide me with an accurate way of doing that. But I know how to program that particular language. It just saves me a lot of time. And I then take what it does and I adjust it to make it fit my exact requirements. But I already know how it works.
If all it is trained on publicly available data, I mean, we've been told not to trust everything on the internet since we were kids.
Oh, hold on a second. The internet wasn't around when I was a kid.
and now we kind of let someone else trust all the information and provide it back to us as truth. And that's also where, as we said, where the private part comes in, right? You have the language model that understands how to interpret human data, which is what an LLM is. And then you feed it with your correct, verified information to provide some value on top of that. So it's the same there as everywhere else. If the quality of content in equals the quality of content out.
Or other spoken, what stays in the head is shit in, shit out. And I think we should be open here about that.
I was going with garbage, but yeah, shit's fine. Yeah, let's just do that. That's good. I was going to say the other. So the bizarre thing here is the fact that what we're saying is that you can do that by trying to create this inside your own environment. So you could put in a large language model inside your internal data center. You need to buy the physical hardware necessary to be able to do the learning. You can then provide it with very specific data, and not necessarily a massive amount of very specific data, but you can use that to then tune the model to meet your needs. Or you could do that by also giving it to somebody like Copilot or what have you. But they then provide the hardware to do the learning, and you still provide the data. But then, while you may ask for that to be private, you're never entirely sure where it all is. Is that the way it works?
Yeah, I mean, at some point you have to trust someone. So if you trust Microsoft,
trust Microsoft.
But that's where the private AI role comes in, right? Because if we have now a prescriptive way of sizing, deploying, managing private AI in the same way we do with server virtualization or virtual desktops or storage or networking, whatever, you keep control of it and you minimize the footprint you need to have to be able to use this brave new world of AI, which is pretty much how to use large language models and not AI as such. But once we can do that and regenerate and create those environments locally in a prescriptive way, we know what we're doing. We know what hardware we need. We know the storage requirements. We know everything. And we can design and deploy it. It'll be much more accessible for everyone to do on that private data without having to share that private data with anyone.
And this descriptive way then can itself be used to just go with any cloud providers, so to say, when you go on the infrastructure level, and not use the software as a service level, but the infrastructure level where you have your own policies and security restrictions that you can apply on. So it will benefit all in the end.
But you do need, I mean, we talked about this in a previous episode, actually, with regard to sort of the data you intend to use and bias within that data. But I think that's something, if you want to utilize AI, the key point really is to make sure that the data that you're providing speaks to the requirements that you want to get out of it, if that makes sense. We talked about stuff in the past with regard to data from certain data over a very short period of time tends not to be big enough to train an AI effectively, but may represent what you do today. But if you feed it data that your business did over the last 10 years, then you may find that from the point of view that way that your business does business has changed dramatically over that period of time. And therefore you're feeding it in the biases for the data that you did historically. So it's a really interesting method of trying to sort of say, well, okay, not only you can't just take a load of data and dump it into an AI and say, there you go. It's not, you've got to be a lot more specific than that. You've got to be a lot more clever about what you deliver.
And it's with everything else, start small, right? Start with something you know. Start with something you can manage and start getting some value out of that, and then grow from there. If you just throw everything in the kitchen sink into a model, you don't know what you're going to get back.
I think that's what we also will see in all our personal belongings, like smartphones and so on. I think they are going the same route. They're using massive training data to create a model that is helpful, and then they will put it down to the smartphones, to your, I don't know, home assistants or whatever, where the data that you are feeding during the usage time will be staying local, but they can update the model over time. So what I found really interesting is with I think it was Samsung, the latest smartphone that they provided or will bring out. I don't know what the current state is. They have actually a bubblefish in there. They have this kind of local translation during your calls. You can only, if I would call you, I could speak in German. You would hear the text in English, you could answer in English, and I would hear it live back in German, and it all would stay on the device. That, at least that's what they are saying. So that is, I think, really, really interesting, and speaks to this private AI thing, but trained models with a huge amount of data somewhere in the back end shrink down to a smaller thing going into the devices.
Well, we found that with Alexa, didn't we? In the fact that Alexa seems almost conversational in the amount of time it takes to do its communication. But in reality, it's taking what we're saying, compressing it, sending it off to Amazon. Amazon are doing the process on it. Sorry, Alexa. And then that data is then coming back almost instantaneously. So there's certainly from the point of view of bandwidth and transfer speed, we can get that data very quickly backwards and forwards. But I can literally talk to you in English and it will real-time translate. That's amazing.
It will real-time. I didn't try it yet, but it will do it on the device.
The Galaxy AI thing, then, right?
I think that's something that maybe we don't tend to think of. We tend to assume that, and this goes back to the point I made earlier, we tend to assume that it takes a massive amount of data to be able to do that. Therefore, we couldn't put it on a handheld device. But that's not the way that AI works. Once you've trained something, all you've got is the brain that understands that thing. And that brain actually isn't very big.
Let's put understand in air quotes, please. But yeah,
exactly. But it's not very big. So if you train a camera to recognize a human being, well, that data that represents this is what a human being looks like is tiny, tiny, tiny. But every time that camera then looks at what represents a human being, it'll go, "There's a human being there. I'll just flag that." And so it understands the shape, the size, the positioning, the movement. It's got all that built in, but it's tiny.
My doorbell actually misidentifies me as animal from time to time. So I don't know what that says about me or my doorbell.
Shave a little bit more often.
For those that know you, Christian, it's not really surprising, to be honest. I was thinking more like Yeti.
Nah. Yeah, but it didn't go specifically into anything but animal.
So bear, possibly. You know, that sort of, yeah, okay. There's a bear in your backyard.
But I think... Nice. What we need on those devices, though, is speedy chips to go through those models, right? And that, I think, is why NVIDIA is now, again, more worth than Amazon, as I read today.
Wow.
Yeah. Because they are providing those speedy chips, NPUs, or however you want to call them, to really go very, very fast in using those models. So very interesting developments there.
We're in danger, though, at the moment of being big issues around the environmental impact of training. Because training, I heard a stat somewhere that something like 20% of all the compute power in the US currently is used to train AIs. And you sit there thinking like, holy mackerel, the amount of electricity, cooling, what have you, that we're currently consuming just to train AIs is ridiculous. So we need to
and then you add the Bitcoin and cryptocurrency mining on top of that, and all of a sudden a very large chunk of the total energy consumption is actually used to just compute things.
That seems a bit bonkers, especially if some of them are of maybe limited value with regard to that. But is it me, or did self-driving cars disappear a little bit from the radar since this all came out? I don't know whether that's a thing, but is this related? Because you would think, I know that NVIDIA were very much involved in that with regard to training cameras and LiDAR systems to understand what's happening when people walk in front of the car. And that's also being generated into an AI. But that seems to have died a death of late. I don't know, I'm just wondering whether is this related to in some way, shape or form?
Yeah, might be related to that expert system thing, because the amount of data that has to be analyzed in a very, very short amount of time is massive. Really, really massive with cars. And when you think about it, it's always impressive that we as humans can do that so easily, because it's insane. It's amazing when you try to code that and see what the hell is happening at the same moment in our brains and what should be happening at this computer brains, which just doesn't. So what I saw, the last information is that Waymo things don't really disappear. They are getting disappeared. There was a mob. I don't know if it was San Francisco, but there was a mob of people just destroying an autonomous car because they block the way and they are really not behaving very good.
Yeah. But it's. I mean, it might be years off, but if you look at what is required from us as human beings to actually be able to drive a car with a bunch of other people also being able to drive their cars around at the same time, the compute power, as you mentioned, Christian, is insane. But I think probably not in my lifetime, but at some point, people are going to look back and what we're doing now and say, what were they guys doing? What were they doing? Are they driving themselves? They're nuts.
Especially if they've seen me drive. I mean, that would be, that's not a good idea, really.
Yeah. Right. So we've been doing it now for 100 years or so. And mainly I'm surprised it goes as well as it does. To be honest, I see a lot of strange stuff out there. And I might be a part of that statistic myself as well, as you mentioned, Tony. But the thing is, we're able to adapt to it quickly enough and understand the ramifications of things. And that's always going to be the kind of AI problem, right? Which kind of moral or ethical decisions do you take at what point, and what do you base that on? And that's really, really hard to kind of programmatically find out how to do. There's this drawing of, I mean, the train going down the train track. Should it go over the old lady or the 5 school kids, right? How do you select? Yeah. And how do you programmatically assign a value to something like that to be able to quickly respond to it? It's really, really hard.
And that's why all the Waymos just stop in that case, because it's better safe than sorry in this
Don't
case.
Kill anybody. That sort of stuff.
I would rather... I would rather that a self-driving car has indecision on identifying me rather than my doorbell misidentifying me as an animal. That's fine. If the car did that and ran over me instead, I wouldn't be quite as happy.
True. Okay, he's only a cat. Let's take him out. That sort of stuff. Okay, so summing up then, what we're really saying is, actually, this has come a long further than I expecting it to. We have a situation whereby we can utilize large language models that exist on the internet, such as ChatGPT and various other elements to train. But we can also utilize, sort of like personalized versions of those that still sit with those providers. So we don't necessarily need all this additional computing power that is required. We don't need to add to NVIDIA's share price by buying a shed load of hardware. We don't need to wait several months for it to arrive, probably on that basis. But we can also do it locally. If we want to be really private about this sort of stuff, we can bring it locally. But if we do, we need a shed load of information to be able to train it with, maybe. But I think it's a lot more flexible than I'd envisage. Christian, Moan.
Yeah, it's true. I mean, you can go download these publicly available models right now. There are models for voice commands. There are for everything, right? So you can do a lot of stuff now based on whatever those tech behemoths have created in their own data centers. We can utilize that locally. And that makes it more open to anyone, pretty much.
Yeah, Christian, thoughts?
Now, just adding in there. So go out and try that stuff, because it's really impressive what your own hardware can already do. And the next generation of personal hardware will have some kind of chips included that help with using and utilizing those models, be it large language models stripped down or small language models with keeping it very small in mind. So that will be very, very interesting. And I think we will see those things also on some kind of edge devices like the security cameras, where they have that processing also on device and not at a cloud provider somewhere in the backend to have more accuracy, to have more speed. So pretty interesting. But you have to understand what you're using. And as Christian said in the beginning, think about what you're doing when you're using those public models and public services. There's a very, very high risk that you accidentally put up something that should not land there, be it PII or just some stupid family photos that could be used for training. So,
and let's all have a phone that does a Babel fish. That'll be great. Sort of like, that's a fantastic idea.